Good afternoon. This is a beginner's tutorial to Igor Pro. Igor is a software for scientific data analysis and plotting. So what makes Igor different to other softwares? So we have, for example, Origin, which is quite popular in science. Many research groups use it to create their graphs for publications. It has a very sophisticated user interface, and you can create the most complicated graphs without ever typing a single line of code. But this makes the user interface very complex, and it also has a bit of a learning curves. On the other hand, I don't see many people using Origin for scripting, and then they use another type of software or a programming language like Python. So Python is a modern programming language. It is excellent for data analysis, but you can also use it to create plots for publications using, for example, the matplotlib plugin. But with Python, you have the situation that when you want to create your plots, you have to program every single aspect of your plot in code, and that has an even steeper learning curve. Igor is kind of a hybrid approach in the middle. It has a user interface, so you can create plots using only the mouse and the available menus, but it has also a scripting language which is quite powerful, and you can use it for all kinds of data analysis. The good thing about Igor is that it uses its own scripting language to describe the plots, and even when you operate it with the mouse, it will show you the commands used for recreating the plots. And by that, you can very easily learn the commands to learn the scripting language. And if you want, then also do all or parts of your work with the command line. I use Igor a lot for data analysis of photoelectron spectra, so XPS and UPS spectra. In this tutorial, I will show you some basic functions of Igor. I'm on a Mac now. Igor is also available for the Windows operating system, and to my knowledge, it is absolutely compatible, both versions. When we start Igor, you will usually see these two windows, so the command line and the data browser. I have these windows open all the time because they are very useful. In case they are not open for you, you can find the command line here under the menu Windows, command window, and you can find the data browser here under data browser. So we use the command line to enter commands into Igor if we want to operate it with commands, and the data browser is used to show you the data contained in your experiment. So what is an experiment? Experiment is how Igor saves graphs and data which belong to the graphs in one file. It can only be one graph, but it can also be all the graphs which are used for one publications. This is up to you. In the beginning, usually I first of all save an experiment so that I don't forget that later, and if, I don't know, my computer crashes, then the data doesn't get lost. So I just save it here to the desktop under tutorial. The experiment files in Igor have the file ending PXP. Yeah, now I want to show you how to make some graphs, and for that we need some data. Of course, there is a lot of functions to import data into Igor Pro, but now for the sake of that tutorial, it's maybe easier if we just to create some data on the fly. Yeah, and to enter data into Igor, we need first of all a table. We can create an empty table from the window menu, new table, and then a menu will come which will ask you to select data to be shown in that table. But since we don't have any data yet, we just click do it, and then we get an empty table. So maybe you have noticed that in the command line, actually here in the history of command line, command popped up, edit. Maybe I can make that a little bit bigger here for this video. And yeah, this is the first command now we learned. So we see that we can also get a table by just typing edit in that command line. From the history, we can easily repeat commands by clicking the upwards key and then selecting the command, pressing enter to bring it down to the command line, and enter again to execute it. And you see by edit we also get an empty table. Actually, now I also make the command line a little bit bigger here. Yeah, this is the first command now we learned. If you want to know more about a specific command, for example, many of the commands have options. We can also show some help for a command by right-clicking on it and then going here, help for edit, which will present us with the help window where we see that the edit actually has a lot of options to specify options of that table. If we want to find commands we don't know, we can also go to the Igor help browser where we are presented with different ways to search in the Igor help, and here we are in the command help tab and can search for commands, also filter here, so we can also find the edit commands here and then see information about that. Also we can filter for other commands, for different functions, for mathematic functions, for windows and other things. Okay, now we want to enter some data. Yeah, we need some X data and some Y data to create a plot. So I will just enter some data here first for X data, maybe 2, 4, 6, 8, 10. 5 data points are enough. And then we enter another column with some Y data, maybe makes this a little bit more interesting and do 1, 4, 8, 4, 1. So something with a maximum. You can see that Igor now created some columns and called these columns wave 0 and wave 1. Why wave? We have to talk about waves later in more detail. For now, these are just the names of the columns. You can see now in the data browser, also 2 items popped up with the names of these 2 columns. And now I first want to create a graph and plot wave 1 versus wave 0 as the X wave. And to create a graph, I go to Windows and then select New Graphs. Then a window comes up and asks me what I want to use for the Y data, which is wave 1. I select it here. And for the X data, which is wave 0. And then I click Do It, and we get our first graph. In a new window, we can move that around and also change the size. In the history of the command line, we also learned now that the command to create a wave is simply display followed by the names of the waves or columns we want to plot against each other. So next I want to change the style and appearance of my plot. So I don't like that style in particular. This is the default style in Igor. And also this is not used a lot. So usually we have the axis mirrored on both sides so that the graph is closed, and usually we also have the ticks on the inside. Also I want to change the appearance of the data. And the data in a graph is called trace. And we can click just on that data, double click on that data to open a menu to change the trace appearance. What I want to do is I want to, instead of a line, I want to have it plotted as markers. So we change the mode here to markers. These are now little crosses. I don't like them. I want to have something more visible. So maybe use this closed circle here now. Can change here the size of that circle, maybe size 2. I don't know, and also maybe change the color to demonstrate it and change it maybe to a dark blue. Useful thing with this color menu is that Igor saves the recently used color here as a little swatch icon. So if you later want to use that specific type of blue again, we can select it here from the recent colors list. Yeah, and then we click do it and see our result. So we see also now we know the command now to change the appearance of the trace for the mode, to change it to markers, the marker type, the size, and the color. Actually, I still think this is quite small, so maybe we increase the size of that markers. Now we know that the command for that is m size, so we can just write modify graph m size gleich maybe 3. Yeah, 3 is much better. So next we want to change the appearance of the y and x axis. I want to mirror them, put the ticks inside. For that I double click on the axis. Now we see the modify axis menu first for the left axis. In the first tab of that we find here in the middle with the axis the mirror option, and I enable that. And if we go to the ticks and grids tab, we find the option here to put the ticks on the inside. So actually you can see for the axis there were a lot of options to change different aspects of that axis and the ticks and numbers written on the axis. Okay, then we click do it and we see now that the y-axis is mirrored. We also see now the command used for that. And we can repeat that command maybe here from the command line now and do the same for the x, so the bottom axis, and also change it to mirrored and ticks inside. Labels would be nice. Every good graph should have y and x axis labels. We can again enter these labels by double clicking on the axis and then go to the axis label option and enter some label here for the y-axis, maybe just y data now for the tutorial. We can also maybe should increase the font size. We can go here and increase the font size to 14 points. You can see that Igor uses escape characters and some commands to change the font size. So here we uses backslash, the escape character, and then that 14 to change the font size to 14 points. So we can do it now. We get the y-axis label. If we want to do the same for the x-axis, we can just repeat the command. We see it's just label. Change this here to bottom and change the label to X data. Okay, now maybe we want to also change the range of both axes. There are two ways to do that. Again, we can go from the modify axis menu and go to axis range, and for the bottom axis we go here manual range settings and change that maybe to increase that to 1 to 11. Then we have a wider range. We see it's simple. The command is simple, set axis bottom 1 to 11. So we can repeat the same for the left axis and change that maybe from 0 to 9. If we there was another way to change the axis range, simply by using the mouse and drawing I think it's called marquee on the graph, and then clicking on this inside of this box and click expand to zoom in or shrink to zoom out. And there was also right clicking on the graph and option auto scale axis to go back to this default settings that the data just fits inside of the chart. I now want to go back to my manual settings for the axis, so I just go to the command line, use the cursor up, and repeat those commands here to get back to my manual axis range settings. Okay, now I want to add a second trace to that graph. And for that, I thought maybe we try out a curve fit. So this looks a bit like that it can fit it by a Gaussian curve. So maybe let's try that. In Igor, the option to do fitting is here under analysis, and then the first option, curve fitting. We can select here a fit function. I want to try out the Gaussian fit. Yeah, this is the formula for that. Maybe you remember that for school. And again, we have to specify which is our y data, which is wave 1, and the x data, wave 0. We can go through the options here. Maybe what I want to change is here in the output option, I want to fit not only within the range of that x data, but the full range of the graph. So I enable that option here. Yeah, and then let's see how it works. It will do the fit. It will show you a progress window here in case the fit takes longer for a more complicated function. And in this progress window, it will also show you the results of the coefficients of that fit. And yeah, you can close it then. And you also see the results of that fit here in the command line. And if we go up, we see the command for the fit also. You see in the data browser, a whole of stuff popped now up. There was first of all another wave or column with the data for that fit. And there was some additional waves with the results of that fit, and some things here which have a different icon. These are variables and are just some meta information about parameters for the fit, for example, the number of points used for the fit, and so on. If we don't want to see these variables, which are in some cases not so important for us, we can also not decide to not show them here in the data browser. Now we only see the waves we created and the waves which contain the results of the fit. Yeah, maybe also change the style of the second trace now we have in our graph. I double click on that. As we see there is now two traces, our data and the fit data. I want to show that as a line is okay, but maybe change that to a black color and maybe change that to dashed line style. Yeah, this looks quite nice for me. Now that we have two traces in one graph, a legend would be nice. I can add a legend here by using right click and then use this annotation menu, add annotations. There were different types of annotations. There was simple text you can add to a graph here as a text box. There was tags, which is basically a text pointing to with the arrow to some data. And there was this legend, and color scale is used for image plots. I use legend and it will show us here a default legend. This is the text. So again, there was an escape character with this S command pointing to that trace. And then there was some text we can change. So in the first line, I want to change that text maybe to our, I don't know, demo data. And then the fit, I want to be more specific and call that Gaussian fit. Maybe also change the font size for that legend. So I go with the cursor in front of the legends and then change the font size again to 14 point. So there was more options about the legends. Some people like to put a box around the legends. I don't like that so much, so I don't use the box. Also the background, usually the fit has a white background, but I like to often change it to a transparent background. I'll show you why in a moment. So I changed it to a transparent background. We now get our legend. Transparent background, the advantage is now that we can have the legend be very close to our data and it looks transparent. It doesn't have a white box in the background. this is a quite nice graph, so maybe now we want to use it for our thesis and our publication. So we want to export it to a file. As shown in the beginning, I can change the size of that graph, but usually for a paper or publication, you want to have a specific size. And this is maybe now the point where you need to find out what is a good size for a graph in centimeters. So for example, for thesis, you have to consider that the page width with the borders at the page is something like 18 centimeters. So a good width for a graph would maybe 15 centimeters. So how can we set absolute graph size? So we click here with the right mouse button on a white space and go to the Modify Graph menu. And here we can change the width and height and margins of the graph. So maybe we change that here to absolute units. The units is centimeter, and make the width exactly 15 centimeter. The height maybe then should be 8 centimeter. And also I like to use absolute values for the margins. So for the left and bottom, we need a little bit more space. So we use 1.5 and 1.5 centimeter. And for top and right, we don't need so much space. So we use 0.5 centimeter. So in total now our graph would be 17 centimeter in width and 10 centimeter in height. And you see now the graph has the absolute width. We can now not change it anymore here, that we have it in a fixed size. Usually you want to have standard sizes for your graphs that you can put them nicely below each other on a page in your document. Now before we export it, I want to do another thing. This is change the name and title of that graph. And the way to do that is again in the window menu, window control. Usually I never go there, I just remember that it's Control Y. So we now see a window where we have to enter a title and a name. So what is the difference? The title, first of all, we can type whatever we want. So I just call it now Gaussian Fit Demo. For the name, we have to be more specific. So Igor thinks a bit like a programming language. And so like for a variable, it likes to have a unique name for each of the important items, for example, for a graph. And also there were some rules about how a name can be made. There were characters which are not allowed for variable names. For example, in a programming language, you wouldn't use a space for a variable name, also not a dot or a backslash, and this is the same in Igor. So we cannot type Gaussian Fit Demo here as the name. You see this is not allowed, and it will tell us that name must start with a letter and contain only letters, digit, or the underscore character. And this is, so usually what I do is in the name, I replace the space by an underscore characters. So names have to be unique. We cannot have two graphs with the same name. You see now we have our title, and the graph also now has a unique name. Why did I do this before exporting the data? So now maybe go to exporting the data. So the menu to do that is under File, Save Graphics. And the advantage is now that Igor will use the unique graph name as the default file name for exporting. And this is quite useful to make sure that you later find your data and can trace back a certain file with a graph to a certain graph in the Igor experiment. That's why I did it before saving. Yeah, and then there's different export formats. There was vector formats like PDS and EPS and SVG. Usually on a Mac, I made good experience with the PDF format, the vector format, and it's compatible to a lot of applications. So we can maybe try that. and just save it to the desktop. And then we can see here we have the file in good quality as a PDF. If we have problem with the PDF format, for example, under the Windows operating system, I don't think it works very well with Microsoft Office and Microsoft PowerPoint. You can also try a pixelated format, and maybe for that a good option is PNG. PNG is a pixelated format, but it has the option to include a transparent background. So what is now white will become transparent. And if you have, for example, a PowerPoint presentation with a colored background, yeah, this will be transparent. Because this is a pixelated format, we now have to care about the resolution. I usually export pixelated formats with a higher resolution of maybe using 2 times the screen resolution. You can try that out and save that as a PNG format. And if we open that with the preview on Mac, we see now that it has a transparent background, and yeah, but it's like pixelated, but with a high resolution. So usually maybe try with the PDF format first, and if you encounter problems, try a pixelated format. Okay, now I used the term wave now already a few times. So we have to talk about waves in more detail. So wave is the Igor word to describe how data is saved in an experiment. So Igor users like to be different, so they call it wave. Actually, you can compare it to an array in a programming language. So now we would have 2 one-dimensional arrays. But these waves have some extra information saved with them and some useful extra functions, which I want to show you. Yeah, as waves are treated like arrays in a programming language, also some naming rules apply to them. So for example, we cannot have 2 waves with the same name in the same place. That would be a conflict. And as with the windows, there are certain naming rules for that wave. So maybe now let's try to rename the 2 waves, give them more specific names like X data and Y data. And for example, we can do that quite conveniently from the data browser by just double clicking on the wave names and then entering some new name for them. So maybe let's call that wave 0 X data. And then wave 1, we call it Y data. So if we try X data now, we can see it's not allowed to have 2 names with the same wave. That cannot work. So we need to call it Y data. So about the naming rules. Usually you should only use names for waves which you would also use for a variable in a programming language. So only alphanumeric characters or numbers, and for the special characters usually only use the underscore characters. Actually now in this new version of Igor you can use other characters. For example, we could use space for between the Y and the data, but then we get something which is called a liberal wave name. You can see now that the wave name here in the table is put in quotes, and that means you can only use this wave name from the command line now by using quotes. So if you want to make a new table with Y data, you will have to put it in quotes here, edit Y data in quotes. Otherwise, you cannot use this wave name. I find this quite inconvenient, so I try to avoid these liberal wave names and only use letters, characters, and the underscore character. Like in a programming language, Igor will not distinguish between upper and lower scale characters. So if I now want to create 2 more waves with X and Y data to show you some of the extra features which waves have, I would have to use different names because names have to be unique, for example, by adding a number. But there was another option, namely that Igor supports to have data folders in one experiment. So now here we see the option new data folder. So within that experiment, we can create another folder, which is not visible on the hard drive, but it is contained in our experiment. And maybe we can now call this test2, and we can select this here, set that as the current data folder. That means now we see in the data browser we have a folder test2, and there was an arrow pointing in it that now we are in this data folder. And now basically this is a new namespace, so we can use the names X data and Y data again without having a name conflict. In the practical application, usually I have, for example, measured different samples, and if I want to have them in one Igor experiment, I have a data folder for each sample with the sample name as the folder name and sort my data into different data folders. Yeah, I want to create now 2 more waves, maybe now with a bit more than 5 points. And for that I want to use another function, namely make. So we go here to data and go make, and here we can make waves with a certain number of points. I want to have 41 points and create 2 more waves with X data and Y data. And we see here also that these new waves are created now in our just created data folder test2. I do that, and we see nothing here because we have to click on the little arrow here to open that data folder, X data and Y data. Again, this arrow is important. That means now we are working in this subfolder. If we want to work in the root folder, we can click and hold the Alt key on the keyboard and then click here before the root folder, and then now we are working in the root folder. It also shows the current data folder here. So now going back to the new data folder test2. I also want to show the 2 new waves in a table. You can also do that conveniently from the data browser by just selecting these 2 waves and then right-clicking on edit, and we get another table now with the 2 waves. To fill the wave X data with some numbers from the command line, I can use a function using the point number. And the point number in Igor has the variable p. So I will demonstrate that. For example, I can type the name of the wave and then use the point number, and then you will see that it will populate the wave just with the point number. And if I want now, I can create a function with that variable p, and then, for example, to have more fractional values, divide the point number by 5 and add an offset. And you see now I have values starting from 2 and then increasing always by 0.2. This is how you can create functions with the point number. So when writing scripts with the variable p, I can access the point number in a wave. If I want to get the data at a specific point, I can also do that. By the way, there is a print command in Igor, like in many programming languages. And if I want to get the data from the wave X data at a specific point, for example, at the first data point, I can write the point number in square brackets. Here 0, and then we get the first data point, and for the last, which will be 40, we get the last data point, which is then 10. The wave with square brackets, you specify the point. Now I also want to fill Y data with some data to try out the functions, and maybe I will again the Gauss function, and maybe 8 times exponent using the point number, and the middle here is at point 20, so I want to shift the Gauss curve to be centered at 20, b minus 20, and then the width maybe divide by 2, and then we have to square it and close the last bracket. That should give us a Gaussian function. Let's plot that to try out if that works. So if you remember, to plot you can just type display. So I display now y data versus x data, and if I didn't do a mistake, we should now see a Gaussian curve. Yeah, so the width is a little bit too small, so maybe we make it 10. Yeah, now it looks like a little bit like the first demo here. So you can see with the point number, you can also create complex functions. So why am I showing that? So very often you have the situation that your X data has data points with always the same distance. And in that case, the whole wave X data here can be described by two parameters, namely the distance between the data points and an offset. In this situation, you can actually include the X data as a scaling in the Y data. And this is what I will demonstrate now. So I want to scale the Y data to include the offset of 2 and the delta X of 0.2. I can do that with the menu data change wave scaling and then select the wave Y data. And we see here now in the scaling we have the mode start and end. And now at the moment it just shows the first and the last data point. If we treat that as x values, the first data point is at the x value 2 and the last value is at the x value 10. Or in another way, you can change that mode here to start and delta, and then the first value is still at the x value 2, but the delta value, so the delta x value, is 0.2. And that information is now saved as metadata to the Y data. If we are just here in this menu as an additional meta information, we can also save a unit for the data. So let's say that this is like data from a photoelectron spectrum. So the unit then for the X data would be electron volt, and the unit here for the Y data would be maybe counts. And we can also save these units here as meta information to the wave. So if we do that now, first of all, nothing has changed. If we look in the data browser and select the Y data, we see here now that information which we entered. So we have the start and the delta value and the unit for the X and for the data. The advantage is now that we can create the same plot by just using the Y data wave. So we can display Y data and see here we get the same plot with the correct X values. And that is because Igor now uses the included information about the scaling and the offset to display the data. We only have to specify one wave for creating the plot. So we could actually also do that by right-clicking here in the data browser on the Y data, and we get the same correct plot. Okay, so now actually also the name Y data is not correct anymore. Actually, this is now XY data. So let's change that, and we don't need that X data anymore because that information is now included in our wave. And so we can actually delete that. So let's try that here. Select the wave and click delete. And now it will warn us that we cannot delete because it is still displayed here in this plot and this table. It can also show us here that it is, if we click on where the object is used, it is used in the plot here, graph 0, and the table. Okay, so we acknowledge that. That means we first have to close the two things we don't need anymore, so the plot and the second table, and then we can delete the X data, and then maybe create another table for the XY data and another plot. The X data is included in the wave XY data. I can demonstrate that to you in a different way by using a cursor on a graph. You can add a cursor to the graph by clicking Control Y, sorry, Control I, and then you get this little sub window here, and from that you can drag a cursor on a graph, and at the bottom here you will then see both the point number where the cursor is sitting on and the X value. You can see it will automatically calculate the X value from the point number and show you the correct X value for each of the data point. And the variable to get the X value is just X. And I can also demonstrate that to you from the command line. So if we go back to the function to create that Gaussian function, we have used P for the point number, but we can also use now X for the actual X value. But then of course now the formula is not correct. We have to change it now. So 0.20 was the maximum of the graph, but actually the X value of the maximum is 6. So we have to change the shift of the Gaussian curve here to 6. And I think also the width is now not correct. We have to change it to a smaller width. And we need to change we renamed the wave, so it's now XY data. And we see we get the same function by using the X coordinate from the command line. So to sum that up, when writing functions, you have the choice of either using the point number, which will give you the point of each row in a wave. If the wave is scaled, you can also use X to access the X value of each data point. We can demonstrate that quickly by just filling the wave with the X values. And you see here, this is the X values which we had in our X wave, and we can just get this monotonously increasing function. For P, we get the point number, and then we can go back to our Gaussian function here. To access a specific value at an X position, you can also do that from the command line by using round brackets. So for square brackets, you get the pound number, and for round brackets, you get the X value. So at the X value of 6 electron volt, we should have the maximum of 8. So we can try that out and enter XY data of the X value 6. And then we should get something like 8. It uses now the X position. An extra feature about this scaled wave is that it includes interpolation. So you can have any number, and even if we don't have a point at that exact position, Igor will linearly interpolate to that specific X position. So maybe if we go to X point 6.05, we don't have a point at this 6.05, it will still interpolate and give us the y value of that Gaussian function there. So it will basically interpolate between the 2 points here and get us the value at 6.05. So if you say, well, I still want to see both the x and y columns in a table, you can still do that. It's just a little bit more work. So from the Windows New Table menu, when we select our XY data wave, there is this option here, Edit Index and Data Columns, and then it will show 2 columns, the same wave, but it will automatically print you the X positions for the data. And the command for that is just .id for index and the data columns. This is a very useful feature of waves, and whenever I import new data to Igor, I will find out if I have this situation that the X data is equidistant points, and in that situation use scaled data. So that wave scaling feature can save you a lot of work. So first of all, for each photoelectron spectra, IV curve, so on, you only need now only one wave with a unique name. And second, when working with the names and waves from the command line, you also need to care about one name. So finally, there is one feature about waves which I use a lot, and this is this node here where you can add extra meta information. So usually for imported data you have measurement parameters, you have the timestamp where the measurement has been done, and what I usually do is that I put these information in this node field here. You can edit this with the cursor, and then you can add these data and say measured on so on, and then you have this information saved here as the node. When I design scripts for importing data, I will usually try to design it in a way that then this measurement parameters are imported in that node field, and then this important information is saved. So finally, I want to talk a little bit about Windows. I don't mean the operating system, I mean Windows now within our Igor experiment. So when you continue loading measurements into your experiment, you will at one point have a lot of tables and graphs open. And some of these graphs are important and you want to keep them. And some of the graphs maybe are just temporary and you want to get rid of them. So there is different ways to close a window in Igor. When you click on the close button on a Mac, this is this red icon, you will see these close window dialog, and you have now different option. You can just close and not save them, or you can save them as a macro. For these tables, usually you can just recreate them with one click, so there is almost never a need to save them. So you can just click no save, and the graph, so the table is gone forever. Of course, the data is still there. There is a shortcut to quickly close any window without saving, and this is by holding the Alt key on your keyboard and then clicking the close the icon, and then the window is gone without asking. For the graphs, usually you spend a little bit more work, so you want to be more careful when closing them. By the way, you can remove the cursor here by just dragging them away and then close this cursor window with Control I. So yeah, for this graph here, probably we spent a lot of work, so we don't want to just kill it. So when we click on that close icon, we probably want to save it. So first of all, you can see here in the tip, you can hide by shift clicking the close icon. So if I just want to hide that window, but get it back later, we can hold the shift key and then click the closed icon, and then the graph is hidden. So where can we find it back? Remember, we have given it a unique name, so we can go to the Windows menu and maybe look here on graph, and here we can get our graph back. So it's good that we have given it a unique name, and there it is back. So maybe we should do the same for the other graph. Also give it a unique name, and then we call it maybe Gaussian XY data. Because this is the first function where we use the XY data. And you see we can, by shift clicking, hide both graphs and find them back here in the window graphs menu. If you have later even more graphs, like, I don't know, 50 or 100, that list might be quite long. There is another way to find a specific graph, and that is here from the toolbar, this window browser icon, and there we have a graphical list of the plots, and you can open them back from this list. So now about the different option. That is the, maybe click again on the close icon, and you see here we can create a recreation macro. So that will be our first macro. So maybe we do that now. And now the graph is closed, but it says we have created a macro. So with the help of the macro, how can we get our window back? So yeah, we find the macro in the command window, which you can open by going to Windows, Procedure Windows, and then Procedure Window. I usually use the shortcut Control M. And here we see the code which is necessary to recreate the graph which we just closed. You see how a window macro is defined by putting it in this window and then end macro, and it has a name here, Gaussian fit demo, and this is an extra info that it is found in the graph menu. So now we have two options. We can just execute that macro from the command line by just typing the exact name, Gaussian fit demo, and then the round brackets, and it will execute that and give us our graph back. I close again with the Alt key and show you another option. This points here to the window graph macros, and you can also get it back here directly and execute directly. This is quite useful, but even more, you can use that as a starting point to create your own macros, to create graphs for different applications. The important thing is that creates the exact graph, given that we have here in the display command the data, y data versus x data in our experiment. What if we don't care about the actual data, but just about the style of this graph? There was another option to create the macro which just contains the style of the graph, and that you can create by going to this menu where we changed the name. This is window control, and from here we have the option also to create a style macro. Let's maybe try that out too. And we see here we get a second macro which looks a bit different in the way that it will not contain the command to display the actual data, but just the commands which are necessary to style that graph. And now we can try that out to copy the exact style of this first graph to the second graph we made by executing this style macro. So again, I copy the name here and then execute it. But before I type enter, I will bring our second graph on top and then execute it. And you see here we copied the same style to this window. Only problem is now that for these data we added the unit, and the unit should maybe be shown not here on the axis but in the label. And we can quickly fix that in the macro by adding something to the label command. You can access the unit with the escape character backslash and then U for the unit. And so we should get the unit now after the X data. Usually in papers you put the units in brackets, so maybe do it like that. Compile this macro here by clicking here, and then maybe we can run it again. And you see now we have the unit, which is part of the data, also in our label. Yeah, this is a way we can create a style with the menus, save it as a macro, and then applying it to a different graph. And this extra information behind the macro name points us to the window where this macro can be also executed, which is here graph macros demo style. So in summary, when creating a macro from an existing graph, we have the option to make a recreation macro, which recreates the exact same graph, given that we have the data with the exact same name in our experiment, and then recreate the graph. Or we can just extract the commands which are necessary to copy that style and use that also for other graphs which can have then data with different names. We can use that as a starting point to create our own macros for making all kinds of complicated graphs. Yeah, and with that, I want to finish this first beginner's tutorial on Igor Pro. I hope that gives you a starting point for your own experiments. Remember that Igor has a very good online help where you can find all kind of informations about the available commands and about also specific topics related to data analysis and plotting. And you can find that to learn yourself about all the different functions you need for your application. And with that, I want to conclude that beginner's tutorial. We have done our first step in Igor, and I want to thank you for your attention.